Hi there, I'm Matt Adams with Loop, and today we're going to be talking about intelligent track technology. Let's start off by talking about some of the precision movers that are on the market today. One of the most common is a rotary dial, where a barrel cam indexes a large plate on a fixed distance over and over again like we have here. These are typically used if you need to do a handful of operations, and they each take about the same amount of time to perform. Now, a precision link uses a similar principle, but instead of rotating a dial, you can see it rotates a series of precision chain links. These are a good choice if you have a lot of stations or if you could benefit from having a straight layout instead of a round one. Now, a walking beam is also cam operated, but those cams use a shot pin to lift and move products. And with a little bit of ingenuity, you can have them move around corners or adjust the pitch on different sections of the beam. Dials, precision link, and walking beams are all fixed pitch mechanisms, so if you need to have any sort of flexibility to route products down multiple paths, or to stop products together for a multi-up operation, then you're going to need to move to one of the varieties of pallet conveyor systems that are on the market, because they can provide that sort of flexibility. Now what we're going to focus on today is this latest offering, intelligent track technology. These allow you to control each product on a shuttle, and it works by filling these tracks with linear servo motors and inverters, which control shuttles that contain permanent magnets. You can direct them to any location, in any path, and synchronize them to outside devices like robots, conveyors, or feeders. Alright, now this is where we need to do a little bit of a huddle up because one of these things is not like the others. I just ended up comparing precision mechanical indexers and glorified conveyor stoppers with intelligent track technology, and we know that those are loaded with copper coils, servo electronics, and feedback sensors. There's an elephant in the room that these are at a totally different price point, right? You're not just going to replace a precision indexer with an intelligent track because it looks cool. But we also know that this technology is being rapidly adopted in industry. So why is that? Well, it's because it gives you the speed and flexibility that allows you to reimagine what's possible. Let me explain. Let's talk about the speed possibilities for a moment. When I say speed, I mean both overall throughput, products per hour, and quite literally velocity. These shuttles can move at 4 meters per second, which is way faster than typical conveyors in a factory. This means that intelligent tracks can be both used in intermittent and continuous flow applications, and as I'll talk about later, there's a ton of possibilities here. Another possibility is to rethink product handling throughout every step of your process. If you have a delicate product state, you'll struggle if all your products must move together like in a dial or precision link. These intelligent tracks offer anti-slosh technology that we see here, and this can address this specific challenge while not reducing cycle time. One of the speed for flexibility trade-offs with pallet-style conveyors is that in order to work on a product, machines need to detect and then raise the pallet to work on it, and then do the reverse to release. Intelligent tracks, on the other hand, know the position of each shuttle and allow you to pre-fire operations as the shuttles stop to get a head start if you need to. So that's the speed part of the equation, and I'm going to shift over to some thoughts on flexibility. So intelligent track's flexibility let you rethink the whole approach to intermittent motion. With fixed pitch movers, multi-op operations are a challenge because if you have one process that takes longer than the rest, then you'll need to pull the products off the mover like we see here and work with it out of sync if you want to keep up. But due to the complexity of that, most designers make a trade-off and they just scale up all the stations to match the slowest one's throughput. But with intelligent track systems, you have another option. You can have optimal cycles by only scaling the slowest stations while letting the fast ones work at their own pace. And this just has a huge impact on floor space, costs, and simplicity of the design by avoiding all the redundancy that so often bloats these styles of machines. Another area where flexibility and speed really shine through is when you have a continuous stream of products that you need to match with an intermittent one. And this has been a really common automation challenge for a long time, and where a lot of revolutionary ideas are waiting to be discovered using the flexibility of intelligent track. Here we have a design from raunchy packaging machinery. It picks up bottles from a continuous flow and then places them between two awaiting shuttles. What's such a game changer about this is that the size of the bottle to be sorted can be adjusted without any mechanical changeover. Loop had a similar challenge when we designed our track packer concept, where a continuous flow of product needed to be synchronized to shuttles, but then later spaced out for intermittent pickup. One of the biggest differentiations of the Acapause track is it allows a fully electric diversion between tracks while at production speed. That gives you the flexibility to mix products from different parts of the machine and route them to different operations on demand. It also lets you sort based on test or inspection results. I hope this gave you some ideas on how the speed and flexibility of intelligent track technology can help you rethink what's possible. If you want to discuss with me, you can reach out to me on LinkedIn or just use my email address here below. Also, I'm curious about what you'd like to learn in upcoming videos, so if you have any thoughts on that, leave a comment about what you'd like to see next.